Okay. Now, previously we have seen about EMF, right? That is electromagnetic induction. In that electromagnetic induction, what is the basic fundamental? Whenever there is a change in magnetic flux, due to change in magnetic flux, there will be a production of EMF. That production of EMF will be in two methods. First is the EMF will get induced due to motion of the coil and magnetic field is uniform. And secondly, the EMF will get induced if coil is at rest and magnetic field is changing. So all the methods we have already seen. Is it okay? Now, whatever that EMF will be induced, now we are going to consider the third type. In that, whenever there is a change in current, so see this diagram. Here is one coil having certain number of turns and across that is connected in series with rheostat, battery and key. If I move the motion of rheostat, then due to change in position of rheostat, the flow of current through this coil will goes on changing. If the current flow will goes on changing, so due to change in current, there will be a change in magnetic field. And due to change in magnetic field, though the coil is at rest, there will be a production of EMF. Right? And here, what the thing happened? There is a change in flow of current in the coil. So I can say that there is change in current in the coil. Therefore, there is change in magnetic flux in the coil. Therefore, there is production of EMF in the same coil. So there is change in magnetic flux takes place in the coil. In the same coil, there is a production of EMF. That phenomenon is to be called as a self-induction. Self meaning is this. That is, change in magnetic flux is in the coil. Due to that, there is a production of EMF is also in the same coil. And that phenomenon is to be called as your self-induction. So now, in this self-induction, whatever change in magnetic flux phi, that is directly proportional to the current. That is, if current increases, phi increases. If current decreases, phi decreases. Therefore, what I can say that phi is equal to Li. L is a proportionality constant. And this proportionality constant is to be called as a self-inductance. So L is nothing but the self-inductance. This is for the coil when there is only one turn is present. But now in this diagram, I have shown n number of turns. So in that, I can say that if there are n number of turns, I can say that magnetic flux produced phi B can be written as number of turns into phi. So this is nothing but your phi, total flux. Means what I can say that this total flux phi B, which is nothing but as a n phi, which is directly proportional to phi. So this is nothing but as your physical quantity, which is to be called as a flux linkage. So this flux linkage, I can express this flux linkage as a n into phi b. This is to be called as your flux linkage. And this flux linkage is directly proportional to the current. Means if current increases, flux linkage increases. If current decreases, your flux linkage goes on decreasing. Right? And therefore now this equation what I can write? N phi b is equal to nothing but Li. Therefore, I can write for L, or I can write for flux linkage. This flux linkage phi b is equal to nothing but Li upon N. Clear? Now, come to this point again. That is, through a coil, whenever there is a change in current, so that there is a change in magnetic flux, that change in magnetic flux we can write down phi is equal to Li. So that there will be, now, due to this change in flux, there will be a production of EMF according to Lee's law. What that EMF? E is equal to minus L. I can say that, sorry, your Lee's law is E is equal to minus d phi by dt. So which is equal to minus, instead of phi, what I am going to substitute? Li. So what I write? d dt of phi is nothing but L into I. So L will be taken out of the derivative, so minus L di by dt. So this is nothing but your EMF. So this is nothing but your EMF introduced inside the coil. Now I can call this is the flux formula, this is the induced EMF formula in the coil in case of your self-inductance. And therefore now here I can give the very first thing, which I am going to call it as, from equation number 2, I can give the unit of inductance. How I can give the unit of inductance? Just consider. Inductance, self-inductance is L. Is how I can, in magnitude wise, in magnitude, what I will say that in magnitude, your EMF E is equal to nothing but L di by dt. Therefore, L is equal to nothing but E divided by di by dt. And EMF is expressed in volt. So what I can say, unit of self-inductance is nothing but, what I can say that, volt. EMF unit is volt divided by di, current unit is ampere, dt, it is second. So what is the unit of inductance? Volt second per ampere. Or volt per ampere is ohm, so I can say it is ohm second. So the first unit is this, volt per ampere per second. Second unit is nothing but ohm second. And the third unit, this unit is equivalent to Henry H. That is the name of the scientist. Like current unit is ampere from the name of the scientist. Same thing. Self-inductance unit is from the name of the scientist as a Henry. So there are total 3 units of inductance. First unit from formula, volt per ampere per second. Second unit is ohm second. And third unit is nothing but Henry. So these are the 3 important units you have to remember very carefully. And after this unit, now we can go for the formula, or I can say definition of inductance. So now for the definition of inductance, I can concentrate on equation number 1. What is equation number 1? Phi is equal to Li. So I can write formula L is equal to phi upon I. So this is my first definition. How I can define? Self-inductance is defined as change in magnetic flux per unit current. That is the first definition. Self-inductance is defined as change in magnetic flux per unit current. That is the first definition. Second definition, that I will give it from the second formula. What is the second formula? EMF produced in the coil is equal to minus L di by dt. So in magnitude, I can write for L is equal to E di by dt. So now I can give the second definition. Self-inductance is defined as ratio of EMF produced in the coil per unit change in current with respect to time. So that is nothing but the second definition. And now I can give the third definition. For third definition, I can take the reference of this diagram. In this diagram, due to rheostat, we can change the current. Means our current change will start from 0 to maximum. I can say peak value of current is I0. So when I move the rheostat position, the current value slowly start increasing from 0 and maximally it reaches to I0. Means due to change in current, there will be a production of EMF. And due to that production of EMF, there will be the work done. You are changing the current, means work is to be done, which is associated with the change in flux. So that I can say that small work done can be written as from the definition of power. So power definition is work done per unit time. While electric power is nothing but E into I. That is a current. Means your small work done dW is nothing but EI into dt. While E is nothing but the EMF produced in the coil, and we have this EMF value. So what I say that by substituting this EMF value, I will get it dW is equal to, using this formula, so dW is equal to E, instead of E I can put the value. What is that? Minus L di by dt into I into dt. So this dt factor will get cancelled. What is work done? dW is equal to minus Li di. This is nothing but the work done. And this negative sign indicates that production of EMF in the coil is such that which opposes the change in magnetic flux. That is the significance of negative sign. Now from this I can find out the total work. So total work done is integration of dW, which is equal to integration of minus Li dt. d answer. Now here variable is what? Vi. Means your current is changing, therefore there is a change in magnetic flux, therefore there is a EMF. And your current changes from 0 to I0. I0 is the maximum current, 0 is the minimum current. So limits of the current is 0 to I0. So now I can integrate this equation. So in the integration, I will get it work done dW is equal to minus L integration of 0 to I0 I di integration is nothing but I square upon 2, and integration limits are from 0 to I0. Now if I put the integration limit, what I am getting? Half L I0 square. This is nothing but my total work done, and this work done is always stored in the form of magnetic energy. Means what I am getting? Magnetic energy. B for magnetic energy, U for energy simply. So magnetic energy stored in the coil when current is changing from minimum value to maximum value is nothing but half L I0 square. Now if I am saying that is your maximum current I0 is equal to 1 ampere. So what happened? I am getting that this work done W I can write down, which is equal to half into L. Means L is equal to what? 2W. This is nothing but my third definition. That is self-inductance is equal to twice of work done in the coil whenever current changes from 0 to unity, because I0 I have taken as a 1. So 0 to unity. So during that whatever flux is linkage, due to that flux linkage there will be a production of EMF, and that EMF gives us L is equal to 2W. So self-inductance is equal to twice of work done when current changes from 0 to unity. So this is nothing but the definition. And here I am getting one more formula, which is nothing but for the magnetic energy. Your magnetic energy is equal to nothing but half L I0 square. Clear? So this we have seen self-inductance in the coil. Now we can switch over to the self-inductance in the solenoid. So now I can say inductance in the solenoid. Now all of you are knowing that solenoid means it is the core over which your coil will be wounded. So I can say there is a winding of coil. So if I am saying that a wire of length L is wounded on the solenoid, so length of the wire is L, number of turns of the coil is N. So I can say small n, that is number of turns per unit length. If I am saying L is small l, length of the wire is small l. So number of turns per unit length is denoted by letter small n. So capital N is equal to nothing but N into L. And in the previous chapter, in using Ampere's law, we have seen the magnetic induction nearer to the center of solenoid is nothing but we have derived mu0 n I. That we have seen. Clear? So now this is nothing but the magnetic induction, the solenoid, equation 1. While when current start changing through this, solenoid, due to that there is a change in magnetic flux. So this change in magnetic flux, that is nothing but, what I can say that this change in magnetic flux I can relate as a N into phi. This change in magnetic flux is directly proportional to the current. Means N phi I can write down, which is nothing but L into, this is nothing but the change in magnetic flux. Due to this change in magnetic flux, there will be a production of EMF. So that production of EMF, that I am going to consider as a nothing but, the production of EMF is nothing but, for that I can consider here phi is equal to nothing but B into A. Definition of phi. Definition of phi is equal to B into A. B is nothing but the magnetic induction which will be introduced inside the solenoid. So I can substitute this as a magnetic induction. And I can write down the formula here. For this phi I can put the value. This phi is equal to nothing but directly proportional, so which is equal to L into I. So that Li I can substitute here, which is equal to nothing but B. B is this magnetic induction, which is nothing but mu0 and I, and A is nothing but the area. So from both sides this current factor will get cancelled. I am getting L is equal to nothing but mu0 and A. N is nothing but number of turns per unit length. So here, instead of this N, now I am going to substitute the value. So here I can say this value is nothing but, here I say N. So for this N I am going to put the value. This N is nothing but N into N. Area is nothing but as a pi r square. So L is equal to mu0 and L. Area is nothing but your pi r square. This is nothing but as your inductance. So now I am going to consider here as your L is equal to, okay fine, if you are not getting this, I will again get it. Just wait. Initially I can consider as a, here I can consider solenoid having length L, number of turns N. So small n is equal to nothing but N into small l. So number of turns N is equal to N into L. This is the first step. The second step I can say that inside the solenoid magnetic induction produced is nothing but mu0. This mu0 I can consider N into I. This is nothing but the magnetic induction produced. While I can say that your magnetic flux produced, which is nothing but total flux produced, is nothing but as a Li, which is equal to nothing but flux leakage, which is nothing but N phi. Phi is a total flux and B is the flux leakage. So what I can say that this L can be written as a N phi B upon I. This is nothing but the L. Now instead of this phi B, I can substitute the value, which is nothing but L can be written as, instead of this N, I can substitute NN. Instead of phi B, can substitute BA upon this current as a I. If I am considered this current as a I factor a small I, because I have considered the current as a small I. So current small I. Now B, value of B I can substitute this. So I can say that here I will get it. L is equal to NL. Instead of B I will write down mu 0 NI area upon I. So this I factor will get cancelled. What I am getting, L is equal to, here I say mu 0 N square. Here is nothing but the L, and here I am getting area of cross section of the solenoid, which I can say as a pi r square. So I can say that inductance per unit length, which is equal to mu 0 N square pi r square. This is the first formula. And the second formula, I can say that the second formula for inductance, that I am going to write down as a, here I say inductance per unit length inside the solenoid is mu 0 N square pi. Instead of radius, I can substitute the diameter. So d by 2 bracket square. So final value we will get it. Inductance per unit length is equal to mu 0 N square pi d square by 4. Mu 0 is constant, pi is constant, 4 is constant. Means what I will say, N by L is directly proportional to N square, directly proportional to the square of diameter. Means inductance per unit length of an solenoid is totally dependent on dimensions, that is number of turns and the radius of the solenoid. So this is about your self-induction. So under self-induction, what points we have studied? The first point we have studied, which is nothing but what is self-inductance. Self-inductance means change in magnetic flux and production of EMF. Both the things takes place in the same coil. That is self-induction. In that self-induction, whatever flux is produced is directly proportional to current. Therefore, I am getting first definition of inductance, which is nothing but L is equal to phi upon I. Second definition, I will get it from Lee's law. L is equal to E divided by di by dt. Third definition we have seen as inductance is equal to twice W. How? Just you can go through video, you will get this. And the fourth thing what we have studied, that is inductance per unit length in the solenoid. That formula I am getting as a mu 0 N square pi d square by 4. Therefore, L by capital L by small l. Capital L is a inductance, small l is a length. So inductance per unit length is directly proportional to N square N square. So this is about the solenoid. Same thing you can find out in the toroid. So for that toroid, all of you are knowing that. What is a toroid? What this toroid is? Can anybody tell me what is toroid? We have already seen what is a toroid. Toroid definition, or you can say inside the toroid. Toroid is like this. A coil, solenoid itself is turned into circular format. So number of turns n. Radius of that toroid is nothing but capital R. So you can say inductance in the toroid. For this inductance in the toroid, now you have to first write down magnetic field in the toroid, which you have studied in the previous lecture. In the Ampere's law, we have seen that is magnetic induction inside the toroid is nothing but mu 0 N I upon 2 pi r. This is the magnetic induction produced inside the toroid. Once you are getting this magnetic induction inside the toroid, then now you have to go for the magnetic flux. Magnetic flux phi is equal to B into A. B is the magnetic induction, A is the area. Now, if I am saying that area of each coil. This each coil having radius small r. So area of each coil I can say pi r square. A is the area of coil. B is the magnetic induction inside the toroid, which is equal to mu 0 n I upon 2r. This is nothing but the magnetic flux. As this is the magnetic flux, so now I can say that EMF E is equal to minus n d phi by d. N is nothing but the number of turns. Now in that number of turns, I can put the value of phi. So EMF is equal to minus n d phi by dt. So d dt of value of phi. This is the value of phi. Mu 0 capital N I upon 2r into bracket pi small r square. I will again repeat. Small r is the radius of this small turn of the coil, and capital R is nothing but the radius of the toroid. So this is the major difference between small r and capital R. Now once you have done that, what I write? Minus n into n is it will become n square, then pi small r square upon 2r, and what here I am getting? Di by dt. This is nothing but your EMF. Now this EMF equation I can compare with your inductance equation. Just concentrate here. This is inductance equation. So in the Lee's law we have studied the EMF can be written as E is equal to minus L di by dt. So if I compare, this is my first equation, this is my second equation. If I compare both the equations, so what I am getting? L is equal to L I am getting as a n square pi r square upon 2r. This is nothing but the inductance of the toroid, and using that inductance of the toroid we can find out the value. Here mu 0 is remaining, so I will write down here as a mu 0, here mu 0. So this is nothing but the inductance of the toroid. Fine? Any doubt? Clear? So I will write all the formulas here again for the revision. So for inductance of the toroid, L is equal to mu 0 n square pi r square upon 2r. This is the inductance of toroid. Then inductance of solenoid, which you have seen, which will be written as an inductance per unit length of the solenoid. So inductance per unit length of the solenoid, which you have written as a mu 0 n square pi d square upon 4. This we have the solved formula. Then we have seen the definition of inductance. Definition of inductance. L. First formula, L is equal to phi upon I. Second formula, L is equal to E di by dt. And third formula, inductance L is equal to constant. This is nothing but your total consideration about the inductance. Fine? Thank you.